I'll introduce permutations with an example. So suppose we take the word math and we want to know how many two-letter code words without repetition we could create. So in other words, I'm not going to repeat and use MM or AA. We could do it the hard way by listing each possibility. This is called the exhaustion method. So we could have MA or AM. We could have MT or TM. We could have MH or HM. We could have AT or TA. We could have AH or HA. Or we could have TH or HT. Now I count 12 code words there. Now each of these code words are actually a two-letter permutation of the four letters. So a permutation is simply an arrangement. So each of these represents a two-letter arrangement of the four letters. Now I could have asked how many three-letter code words. So like for instance, I could have had like MAT, MTA, ATM, etc. And I even could have asked how many four-letter code words I could have. Like for instance, I could have had MATH, or I could have HTAM, or I could have TAMH, and so forth. But anyway, these are considered to be permutations because the order matters. So what is a permutation? A permutation of a set of distinct objects is an arrangement. So it has to do with the ways the objects are arranged in a specific order without repetition. So I'm going to say this throughout, that if repetition is allowed, you can't use permutations or combination formulas. You have to go back to the multiplication principle. So just remember that. Okay, now consider the example, math. MA is an arrangement of two of the four objects, MATH. And repetition was not allowed. And MA is a specific order, because AM would be a different code word. So since MA and AM would be different code words, then these are permutations. So we're looking for permutations. And so actually each of the 12 code words is a different permutation. And by the way, I could have came up with the number 12 up here by just saying, how many ways could I choose the first letter, and that would be 4. And then since there's no repetition allowed, how many ways could I choose the second letter, 3, and that would have given me 12. So I could have done this using the multiplication principle, because that's really what the what permutation formula is. It's the multiplication principle that doesn't allow repetition. So, but we'll see the formula here in a bit. Okay, let me continue explaining permutations for you just to kind of give you a feel. Let's list all of the 3 object permutations from the set 7, 3, 6, 4. Well, if you look at this first row right here, you'll see I started with 7, 3, 6, and then I wrote all of the other ways that you can arrange 7, 3, 6. So there's 6 there. Well, then I chose, in the second row, I chose 7, 6, 4, and then copied down all the ways I could arrange those. And so there's 6 ways I could arrange those. And then the next one was 7, 3, 4, and all the ways I could arrange 7, 3, and 4. And then finally 3, 6, 4, and all the ways I could arrange them. Well, if you'll notice, I have 4 rows of 6 sets. So 4 times 6 is 24. So again, I could have done this with the multiplication principle. There's 4 ways to choose the first number, 3 ways to choose the second number, and 2 ways to choose the last number, which is 24. Now, if I had allowed repetition, this would not be permutation. I would not use a permutation formula. I would use the multiplication. Have to use the multiplication principle. I would have to say there's 4 ways to fill each spot, and that would give me 64 possibilities. Look at this example. Suppose a police officer must line up 5 people for a witness to identify the perpetrator. How many ways can the police officer line them up? Well, ask yourself some questions. Can you repeat the people? Can you put the same person in position 1 and position 3? Of course not. So you can't do that. So repetition is not allowed. Is the order relevant? Of course it is. If I put the perpetrator in position 1, that would be different than putting the perpetrator in position 2. So that order is certainly relevant here. So this is a permutation question. But we can solve permutation questions with multiplication principle because, again, that would tell me there's 5 ways to fill this first spot, there's 4 ways to fill the second spot, 3 ways to fill the third spot, 2 ways to fill the fourth spot, and 1 way to fill the last spot. So this is a permutation of 5 objects out of 5 objects. So in this case, I'm doing 5 out of 5. Later, you'll see that we can do permutations where we only pick 3 of these people out of 5 or 2 of these people out of 5 and how many ways we can arrange those. But this is 5 out of 5. And you might also note that that's the same as 5 factorial. This right here is just emphasizing that without repetition and specific order are important. So again, if repetition is allowed, you cannot use these formulas in this section. You have to use the multiplication principle. And also, if the order is not relevant, in other words, if you just want to know how many subsets there are of something, then you'll use combination formulas and not permutation formulas. So you can pause the video and read the rest of this paragraph if you want. But let me go ahead and talk about permutations. I'm going to start with a special case. This is a special case permutation. So how many ways can you arrange all of the objects? So in this time, I'm going to want to know how many ways I can arrange all the objects. So suppose you have n objects and you wish to arrange all n of them in a specific order, like we did with the 8 amino acids. Well, this is a special permutation, and a special permutation has a special permutation formula, NPN. And anytime you're calculating a permutation where the total number of objects you have and the number of objects you're selecting is the same, then the permutation for that would just be n factorial. So there's other ways you can identify permutations. You can do p n comma n, or you can do p with an n comma r here, but either way it's going to be n factorial. So let me give you an example. How many ways can you turn in a batting order for a baseball team if you only have 9 players? Now, you might remember that a batting order for a baseball team is only 9 positions. So basically, you have 9 batters and you have 9 positions. So let's ask ourselves a couple of questions. Is repetition allowed? Could John Doe bat first and third? No. So repetition is not allowed. So that would be cheating. And order is relevant because if John Doe bats first, that would be different than John Doe batting 5th. So we actually have a permutation problem where we have a total of 9 objects and we want to know how many arrangements we can make from 9 objects. So in other words, how many 9 object arrangements can we make out of these 9 objects? And so that would be 9p9, which is 9 factorial. And you can use a calculator to get the number that I got there. The next example says there are 6 horses in a race. How many orders can the 6 horses finish? Well, again, I'm wanting to know, I've got a total of 6 horses, and I want to know how many ways all 6 can finish. So this would be 6p6, which is simply 6 factorial, 720. And then if you go back to the amino acid problem, this is a little bit more detailed. It says a protein molecule in biology called vasopressin is the simplest protein and is composed of 8 amino acids that are chemically bound together in particular order. The order in which these amino acids occur is of vital importance to the proper functioning of vasopressin. If these 8 amino acids were placed in a hat and drawn out randomly one by one, how many different arrangements of these 8 amino acids are possible? Well, again, I have a total of 8 amino acids, and I'm going to arrange all 8 of them. So 8p8 by definition is 8 factorial, and again you can use a calculator to get 40,320. On the next video, I'll give you the general permutation formula, and we'll work some examples from that.